Now it's your turn to use the order of operations to simplify a couple of numerical expressions. Stop this video, take a moment to write out your answers to these problems in your lecture outline packet, and then turn the video back on to check your answers. In this first example, we have 5 plus 12 divided by negative 4 times 3 plus 1. The only thing written in parentheses is the number negative 4, which is written in parentheses in order to distinguish that that's a negative sign and not a subtraction sign. So as we go through, we have addition, division, multiplication, and then addition again as our operations. We'll apply the division and multiplication first. Again, since multiplication and division are on the same level, we will work left to right in applying those. So we have 5 plus 12 divided by that negative 4 times 3 plus 1. Note that the multiplication symbol, there are a lot of different symbols that can be used for that. Here we have an asterisk. It can also be written as a solid dot or the standard cross multiplication symbol. So applying that division and multiplication, we have inside, in these middle expressions here, we have 12 divided by negative 4. So working with this expression, 5 plus 12 divided by negative 4 times 3 plus 1. We're going to compute the division and multiplication first. So looking inside there, that 12 divided by negative 4 times 3 is what we'll work with first. The addition will be done afterwards. So, working left to right with that division and multiplication, we'll take 5 and we have plus, and now we will first do this 12 divided by negative 4, and that will give us negative 3. So we'll have 5 plus negative 3 times positive 3 plus 1. Next, we'll compute that multiplication. So we'll have 5 plus negative 9, which we get from taking negative 3 times positive 3, plus 1. At this point, we have both addition as two addition operations. So we will simply work left to right. 5 plus negative 9 will give us negative 4. And we still have plus 1 on the end. So 5 plus negative 9 plus 1 gives us negative 4 plus 1. And simplifying that as our last step, negative 4 plus 1 computes to negative 3. In the second example, we have a horizontal fraction. And in the numerator, we have 2 squared minus 5 squared. And in the denominator, we have the quantity 2 minus 5, which has then been squared. So again, this horizontal fraction bar works on the same level as parentheses does. So taking that, 2 squared minus 5 squared is in our numerator, and the quantity 2 minus 5, that quantity squared, is in our denominator. So we'll work with that numerator and denominator independently. In the numerator, 2 squared minus 5 squared, we have two numbers that are squared, and we have subtraction. So we have exponents and we have subtraction. Exponents precede subtraction, so 2 squared will become 4, and 5 squared will become 25. So in the numerator, we have 4 minus 25. In the denominator, we have the expression 2 minus 5 in parentheses, and that's been squared. So we'll apply the parentheses first, and 2 minus 5 will simplify to negative 3. So in that denominator, we'll have the quantity negative 3 squared. In our next step, that numerator, we have 4 minus 25. That will simplify to negative 19. In the denominator, we have the quantity negative 3 squared. And since negative 3 itself has been squared, that's negative 3 times negative 3, which will give us positive 9. So that entire expression simplifies down to the fraction negative 19 over 9. We could keep that as negative 19 over 9, or we could write it as the negative of 19 over 9. Noting that 19 is prime, that fraction won't simplify any further.